Alright, video ended. This is the element. X is an element of the reals. You can plug in anything that's a real number and it will work. There's no stipulations to what you can plug in. Informally, you just say X is any real number. Alright, let's keep moving on here. Okay, find the domain and range of the following functions given their graphs. It didn't state how you need to do it, it just says do it. So let's do this one. I can specify with a D that this is the domain. You can make a better D than that. So the domain is X such that X is greater than or equal, because I've got a closed dot, -1. Anything this way is good. The range is Y such that for range use Y. Anything above -3. So Y is greater than or equal to -3. I use the equal symbol because I can be -3. It's a closed dot. This is just the origin right here. Okay, so that's not an open dot, it's just the origin. So in this scenario, the domain is X such that X is an element of the real numbers. You can put in any that goes all the way to infinity this way, it goes all the way to infinity this way. The range is stuck. It has to be below 1. Stuck. So the greatest you can be is 1. So we're going to say Y such that Y is less than or equal to 1. That's the range. In this one, you got some asymptotes going on. So as far as X goes, it looks like you have to skip over X equals 2. You're not ever going to be, so X such that X does not equal -2. And the range, if you're looking at the range, it looks like you skip over Y equals 1. You never reach Y equals 1. You got an asymptote here, you got an asymptote here. So Y such that Y does not equal 1. There you have it. Next, state the domain and range of the following functions. So here's where we can use our calculator to help us actually. So get out your calculator. And we're going to graph this function. So you go into Y equals, you do the square root, and you all need to do this, you need to practice. X minus 5, you press the over arrow to kind of get out of the square root, so there it is. There it is, the square root of X minus 5. Let's go ahead and look at what's happening here. Graph. There it is. And it looks like it starts at 5. 1, 2, 3, 4, 5. Starts at 5, and it's just going to go forever. So the domain is X such that X is greater than 5. And now you got to ask yourself, can I be equal to 5? All right, can you plug in a 5? Does 5 work? What's 5 minus 5? 5, 0. Square root of 0 is 0. So when you plug in 5, you do get out a value. So you can be equal to 5. Now let's look at the Y value. Y value, you can't be less than 0. There's no such thing as a negative. You can't get a negative out of square root. So you're always going to be positive. So you're always going to be positive Y. So there you have it. That's the domain and range. Next, let's do the next one. 1 over X plus 5. And this is where I would have you stop the class and you'd do it on your own. 1 divided by, in parentheses, X minus 5. Like that. Make sure you put the parentheses or else it will be different. So we're going to graph that. Alright, this is hard to see in the graph, so you have to understand the function a little bit, but we do have a asymptote right here, and this goes forever this way, and it goes forever this way. So as far as the left and right, you just have to skip over 5. You have to skip over 5. So the domain is x such that x does not equal 5. Why do you have to skip over 5? Because if you plug 5 in, you get 0, and that's not allowed. You can't have 1 divided by 0. The range is y. Now, as far as the up and down goes, you have to skip over 0. You can go up, you got to jump over 0, and then you can keep going up. So y does not equal 0. Okay, do the next one. This is the square root of x minus 5. Delete that part. Alright, there it is, 1 over the square root of x minus 5. And this one, our calculator's going to not do us justice all that much. This is actually an asymptote right here, but the calculator stops right there. This actually is an asymptote. And if we look at the table, let's look at the table. Here's the table of values. You can see that at 5, it's not allowed. 5 is an error, but after 5, it's good. You can see what's happening. As I increase x, I'm getting closer and closer to 0. This one's a little bit more challenging, but the domain is x such that x is greater than 5. You can't plug 5 in. 5's not allowed. 5 was allowed here, but 5's not allowed here. Why? Because if I plug in 5, I get 0. I can't have 1 over 0. And the range was y such that y was greater than 0. We'll never reach 0. And let's just look at our old friend, the natural log. Hopefully you remember what that looks like. So the natural log of x is right there. There it is. And you can see that it doesn't cross 0. There's no negatives. So you can't plug in any. The starting point as far as left and right goes is 0. In fact, you can't plug in 0. If I did second calc value 0, you don't get anything. So the domain is x such that x is greater than 0, and the range is y such that y. Now this is your up and down. What's the lowest that you can go? It actually goes forever. And it also goes forever up this way. So we say that the domain and range is x has to be greater than 0, y could be anything. Is an element of the reals. That's how we say that. Okay, when we're looking at graphs of functions, there's some key elements that you need to identify. You've got your intercepts. These are your x-intercepts and your y-intercepts. Those are important. You've got your maximum turning point and your minimum turning point. This is called a local maximum and a local minimum, because if you zoom in on it, this is bigger than any point around it. If you zoom in on this locally, it's smaller than any point around it. Is this the absolute maximum? No, because there's values over here that go above this. But locally, it's the maximum. Endpoints. So like on a square root function, you got an endpoint. Keep those in mind. And then asymptotes. Let's talk about asymptotes. Lines that the graph get closer and closer to as they extend to infinity. So this axis and this graph, they're going to become closer and closer and closer, but they're never actually ever going to touch. It's going to asymptote. They're going to become each other, but they're never going to be each other. Interesting. You can have vertical asymptotes, So like this is going closer and closer and closer down to infinity, but it's never actually going to get there. You can have horizontal asymptotes, or you can have actually slanted asymptotes as well. If we were in AB Calc, we would do that. Horizontal and slanted asymptotes can be crossed, so you can cross an asymptote. You can have something that looks like this, where you have a graph. Let's say this is an asymptote. You can have the graph kind of go like this, and it will just kind of oscillate forever over that asymptote. But as it goes to infinity, they become one. They become each other, but they never be each other. Vertical asymptotes, on the other hand, cannot be crossed. You're stuck. You cannot cross the vertical asymptote. You can cross horizontal asymptotes, but you can't cross vertical asymptotes. Alright, the rest are just some examples. Consider the function of the following here. And we're going to do this in our calculator. So get out your calculator, you need to practice. The function that we're working with is 2 to the x divided by x minus 2. There it is. 2 to the x divided by x minus 2. I'm going to do zoom 6 so I get my standard window. There it is. Looks like we got a little asymptote action there. There's some stuff going on here. Interesting. So let's figure out what's happening. Find all the intercepts. Well, it looks like there's an asymptote here, and there might be an intercept there. Maybe we should zoom in and see. Let's zoom in and see. So you can actually press zoom in, enter, and there's a little cursor there. You can kind of see it, and I can zoom in where I want to zoom in at. I'm going to zoom in. I zoomed in, and ooh, yes, it does cross just slightly. Let's zoom in one more time. I'm going to zoom in right there, and you can see it does cross, and it crosses again. Okay, so here's how you can find those intersections. You can press second, calc, intersect. You all need to do this. These are easy points. Now it says first curve. Pick the first curve that you want to intersect. So you see that? It's just going to go there. Press the second curve. Where's the second curve? Oh, silly Mr. Smith. Forget that. Hold on. I pressed the wrong button. Zeros. We want to know the zeros. So it says go to the left. Remember, this is the x-axis, and this is the line where we're needing to intersect. So what you do is you go to the left of your intersection. So you got to take your little cursor and go to the left. And press enter. Now go to the right. There it is. And there we have it. I want to find the intercept in this interval, which is right there. Press enter one more time, and it will give you the intercept. 1, 0. So the intercept is 1, 0. And let's find this intercept now. Go do that. So second calc. This is a 0. We need to go to the left, which is there. We need to go to the right, which is there. We'll find it in this interval. 2, 0, 2, 0. Okay, so those are our intercepts. Find all the turning points. So there's a turning point here. There's a minimum, so let's find that. Find that turning point. We're still zoomed in. Minimum. Go to the left of the minimum. Go to the left of the minimum. And now I'm on the left side of this minimum. Now go to the right of the minimum. Still zoomed in. And there it is. It's going to guess in that interval. The minimum is negative 0.1158. So there's a turning point at 1.44 and negative 0.116. And that is a minimum. Let's zoom back out. So zoom 6. That'll get me back to the standard window. I think this was the only turning point. It's where we went from decreasing to increasing. This is always increasing here. Sorry, it's decreasing. We're going down and down and down. So that's the only turning point of that graph. Any asymptotes? So there's definitely an asymptote at the vertical, in the vertical fashion here. So that is the asymptote x equals 0. Vertical lines are always x. Remember that from the last lesson we did. Looks like there's a horizontal asymptote right here. And I'm going to go look at my table, actually. My table of values. So click table. And I'm going to go backwards. I'm going to go to negative infinity and see what happens. So these are my x values. So look at what happens to the value as I get more and more negative. It's becoming negative 2. There's an asymptote at negative 2. That's our horizontal asymptote. The domain. Let's look at our domain. So zoom 6 back to here. We're going left. We have to skip over 0. And it looks like we can go forever. So it looks like as far as the domain goes, we just have to skip over 0. So domain x such that x does not equal 0. Looks like the range is a little bit more funky. The range skips over from negative 2 up to 0 up to this value here. So the range is going to be a little funky. So the range can be less than negative 2. So we can have less than negative 2. It can't be equal to negative 2 because it's an asymptote. Or we can be greater than that minimum. We can be above this minimum. And the minimum was negative 0.166. 0.116. So there we have it. I could be less than the asymptote, or I could be above the minimum as far as y goes. And it says draw the function. So I'm not going to do that right now. You can do that on your own, but you'd have to draw. You'd have to label your axes, and you have all of this information on your graph. Okay, next. Find the domain and range of the function shown in the graph. So this is car parking charges, and you get charged by the hour. I'm just going to do it informally. This is your range right here. The values that you could possibly pay. You put in hours, it gives you out something that you have to pay. Now the range, the domain, is t, such that we start at 0 and we go up until 24 hours. We include 24 hours. We do not include 0. So that would be like our domain in this problem. And it's not that I'm skipping, it's that I'm jumping. I'm jumping from here to here, from here to here. So I'm not skipping over any values. It's not like time jumps over 12 for some reason. It's that it just goes up to a new charge. Okay, I've got 20 seconds to fit this in. Which one of these has a range of all reals? That would be 3. Which one has a range of greater than or equal to 2? That's this one. Which one has a range greater than 0? It's this one. This is a asymptote. You can't really see it, but that's 2. And which one is